Hi students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing UCM. We'll be doing the numericals of uniform circular motion. Let's see this. Take down please. A body of mass 3 kgs, a body of mass 3 kgs is tied to the free end of a string. A body of mass 3 kgs is tied to the free end of a string of length 2 meters. The body makes 420 rpm. The body makes 420 revolutions per minute. Calculate the linear velocity, the centripetal acceleration. Calculate the linear velocity, centripetal acceleration and centripetal force. Right? Let's see this first. They've asked you to find out linear velocity. Linear velocity. Now guys, when frequency is given to you in RPM, you have to convert it into RPS. To convert it from RPM to RPS, you have to divide by 60. To convert from revolutions per minute to revolutions per second. Now, linear velocity V is equal to R omega. Omega is nothing but 2 pi n. You have the value of n, you have the value of R, you should get the linear velocity. Next, second part of the question, find out centripetal acceleration. Centripetal acceleration A is nothing but V square by R. I have already found out V divided by R, you will come to know this. And C, the third part of the question, centripetal force. Centripetal force is given by the formula F is equal to ma. A I have already found out. Now the answer for this is going to be 87.98 meters per second. That's your linear velocity. Acceleration is going to be 3870 meters per second square, and force should come to 11610 newtons. Take down next one please. A 1.5 kg mass, is rotated in a horizontal circle, of 30 centimeters. Is rotated in a horizontal circle of 30 centimeters. Calculate centripetal force. Calculate centripetal force if it performs 120 rpm. 120 rpm means 120 upon 60 rps. They've asked you to find out centripetal force. Now, centripetal force is equal to m omega square r. Another formula for centripetal force is m omega square r. Omega can be written as 2 pi n, so m into 2 pi n the whole square into r. You have n, you have 2 pi m and r, you should be able to get the answer for this. Pi is 3.14 or you can take it as 22.7. The answer for this should be 71.08 newtons. Next, take down next one please. The frequency of a particle performing UCM, changes. The frequency of a particle performing UCM changes from 60 rpm to 180 rpm, changes from 60 rpm to 180 rpm in 20 seconds. In 20 seconds. Calculate the angular acceleration. Calculate the angular acceleration. Now guys, angular acceleration is change in angular velocity upon time. Angular velocity is nothing but 2 pi. So this is 2 pi n2 minus 2 pi n1 upon time. 2 pi common, n2 minus n1 upon time. You should be able to get the answer for this. The answer for this should be 0.6284 radians per second square. Right? Take our next one, please. The minute hand of a clock. The minute hand of a clock is 10 centimeters long. The minute hand of a clock is 10 centimeters long. Calculate the linear speed of the tip. Calculate the linear speed of the tip. Now since this is minute hand, the time covered by a minute hand is 60 minutes. In one revolution it covers 60 minutes. 60 minutes, that is 60 into 60 seconds. Right? Now I can say that linear speed is going to be distance upon time. When it moves along, moves in a circle, the distance that it covers is the circumference upon time. So you will come to know the linear speed 2 pi r upon time. The answer for this should come out to 1.746 into 10 raised to minus 4 meters per second. Next, take on next one please. A certain string breaks under a tension of 45 kg weight. A certain string breaks under a tension of 45 kg weight. A mass of 100 grams. A mass of 100 grams is attached to the string of length 500 centimeter. Is attached to the string of 500 centimeters. Find the maximum number of revolutions. Find the maximum number of revolutions per second without breaking the string. Find the maximum number of revolutions per second without breaking the string. Now F is equal to mr omega square. Omega, F is given to you length. Length is nothing but your radius. Omega is nothing but 2 pi n. So I can say F is equal to mr 2 pi n the whole square. F is equal to mr 4 pi square n square. Therefore n is equal to F upon 4 pi square mr. Right? Under root, because that was n square. Substitute the values, you should get your answer. The answer for this should be 4.726 Hertz. Next, to stimulate the acceleration of large rockets, astronauts are spun at the end of long rotating beams. Astronauts are spun at the end of long rotating beam of radius 9.8 meters. Astronauts are spun at the end of long rotating beam of 9.8 meters radius. What angular velocity is required? What angular velocity is required to generate a centripetal acceleration? What angular velocity is required to generate a centripetal acceleration 8 times the gravitational acceleration? 8 times the gravitational acceleration. Very simple, straightforward. A is equal to r omega square. Therefore, I can say omega is a upon r under root. Right? They've given you a. G can be taken as 9.8 meters per second square, and you should be able to get the answer for this. The answer for this should be 2 root 2. Next, a coin is kept on a horizontal rotating disc. A coin is kept on a horizontal rotating disc at the center of at a distance of 0.1 meters from the axis. If the coefficient of friction is 0.25, if the coefficient of friction is 0.25, find the speed at which the coin would slip. Find the speed at which the coin would slip. Now let us assume, let v be the speed at which the coin will slip. Okay. Now I can say that the centripetal force is going to be counterbalanced, or is going to be produced by the force of friction. For the coin to just remain there without slipping, the centripetal force should be equal to the force of friction. Centripetal force is nothing but mv square by r. Force of friction is mu mg. M and n gets cancelled, so you will get v is equal to mu rg under root. Substitute the values and get the answer. The answer for this should be 0.4950 meters per second. Right? Next, what angular speed should the earth rotate? What angular speed should the earth rotate about its axis so that the apparent weight of the body on the equator is zero. So that the apparent weight of the body on the equator is zero. What will be the length of the day at that time? What will be the length of the day at that time if the radius of the earth is 6,400 kilometers? If the radius of the earth is 6,400 kilometers and g is 9.8 meters per second square. Let us assume that omega is angular speed of the earth. Since the weight on equator is zero, That means the centripetal force should be counterbalanced by the centrifugal force, only then the weight will be 0. Centripetal force should be equal to centrifugal force. Centripetal force is nothing but mr omega square. Centrifugal force is mg. Omega is g upon r under root. Right? That should be the angular speed with which the earth should rotate, so that the weight of a person on the equator becomes 0. Right? Now, also omega is 2 pi upon t. Therefore, I can say t is nothing but 2 pi upon omega. So I'll come to know the length of the time there. I'll get the time in seconds. The answer for this should be omega is 1.237 into 10 raised to minus 3 radians per second, and time should be 1 hour 25 minutes. Right? Next, take on next one please. A motorcyclist rides in vertical circles. A motorcyclist rides in vertical circle. A motorcyclist rides in vertical circles in a hollow sphere of radius 4 meters. Find the minimum speed required. Find the minimum speed required so that he does not lose contact. So that he does not lose contact with the sphere at the highest point. He does not lose contact with the sphere at the highest point. Now we know that g is 9.8 meters per second square. Let us assume that let v be the minimum speed of the motorcyclist. Let v be minimum speed of motorcyclist. Right? In which case, if he does not lose contact, that means the centripetal force should be equal to the gravitational force. Right? Centripetal force is nothing but mv square by r. Gravitational force is mg. Right? In that case, I can say that v is square root of rg. The answer for this sum should work out to 6.26 meters per second. Find the angle that a bicycle and a rider makes. Find the angle that a bicycle and a rider makes with the vertical. Find the angle that a bicycle and a rider makes with the vertical going at 1800, sorry not 1800, 18, going at 18 kilometers per hour. Going at 18 kilometers per hour. On a road of radius 10 meters. On a road of radius 10 meters. Let us assume let theta be the angle made. Then I can say that tan theta is nothing but v square by rg. So you will get your value of tan theta. Take tan on the other side. So you will get theta is tan inverse of v square by rg. Right? Find the tan inverse from the logbook. You should get the answer for this as 14 degrees 19 minutes. Right? Take out next sum please. Find the maximum speed of the car. Find the maximum speed of the car which can be safely driven on a road of radius 150 meters, if the coefficient of friction is 0.25. If the coefficient of friction is 0.25, let V be the maximum speed. Okay. Now, therefore, I can say that centripetal force should be equal to the force of friction so that the car does not skid. That means I can therefore say that mv square by r should be equal to mu mg. So you will get V is mu rg under root. You should get the answer for this. The answer for this should be 19.17 meters per second. Next, a train of mass 10 to the power of 5 kgs, a train of mass 10 to the power of 5 kgs curves a radius of 150 meters, at a speed of 20 meters per second. At what angle must the track be banked? So that there is no thrust on the rail. Also find the horizontal thrust. If the track is not banked. The thrust that will be given or will be exerted on the outer rail will be nothing but the centripetal force, right? So in that case, I can say that centripetal force we know is nothing but mv square by r. V is given to you, r is given to you, m is given to you. You should get this angle. Let theta be the angle of banking. If theta is the angle of banking, then I can say that tan theta is v square by rg. Therefore, theta is tan inverse of v square by rg. Right? You will get your angle of theta. The answer for this should be the horizontal thrust is 2.667 into 10 raised to 5 newtons, and the angle at which the rail should be banked is 15 degrees 13 minutes. Right? Take on next one, please. Find the angle of banking of a curved track of radius 800 meters if the maximum speed limit is 54 kilometers per hour, if the maximum speed limit is 54 kilometers per hour, if the distance between the rails is 1.8 meters, find the elevation of the outer track. Find the elevation of the outer track. Straightforward. Let theta be angle of banking. So in that case I can say tan theta is V square by Rg. Therefore theta is tan inverse of V square by Rg. Right? Now once you have this, you have also got to find out to what extent is the outer rail elevated. They have given you that the distance between the tracks is 1.8 meters. This is your angle of banking. Let us assume that it is elevated to a height h, in which case I can say that sin theta is h upon L. Therefore h will be equal to L sin theta. Theta I already found out from there. L is given to me as 1.8, so I will come to know the extent to which the rail is elevated. The answer for this should be theta is 1 degrees 39 minutes and the angle of the height of elevation is 0.05166 meters. Right? Take our next up please. A particle revolves in a circle. A particle revolves in a circle of radius 0.4 meters at the rate of 600 rpm. At the rate of 600 rpm. Calculate the period, angular velocity and linear velocity. Calculate the period, angular velocity and linear velocity. Fine. Now, first of all I can say time is 1 upon frequency. Right, so time I'll straightforward get because frequency is given to me. Next, angular velocity omega is 2 pi n. Again I can get the answer. N is given to me. Next, linear velocity v is r omega. Omega I just found out, so I'll get the answer for this. The answer for this should be t is going to be 0.1 seconds. Omega should come out to 62.84 radians per second and linear velocity v should be 25.136 meters per second. Right? Next, let's see another sum guys. A body of mass 800 grams, a body of mass 800 grams, a body of mass 800 grams moves in a circle of radius 1.5 meters. Moves in a circle of radius 1.5 meters at 180 rpm. At 180 rpm. Find the angular velocity. Find the angular velocity, the linear velocity and the tension on the string. Find the angular velocity, the linear velocity and the tension on the string. Right? Angular velocity omega. Angular velocity is nothing but 2 pi n. Linear velocity r omega. And the third thing they've asked you, tension on the string, that is force, is nothing but mv square by r. All the things are given to you, straightforward sum. The answer for this should be omega is 18.852 radians per second. Then you have linear velocity v. Linear velocity v is 28.28 meters per second, and F force is 426.5 newtons. Next, a motorcycle is traveling at a speed of 80 kilometers per hour. A motorcycle is traveling at a speed of 80 kilometers per hour on a road of radius 40 meters. On a road of radius 40 meters, banked at 30 degrees, is the motor car or motorcycle safe? Is the motorcycle safe? Now first let's find out the maximum speed. We'll call that as say V1. Now we know that tan theta is V square by Rg. Therefore I can say that V is square root of Rg tan theta, right? When you solve this, you will get the answer for V1 to be 15.04 meters per second. That is the maximum speed at which you should be driving. And the speed at which V, when you do that conversion, the speed at which the motorcycle is going is 22.22 meters per second. Right? Since the speed at which the motorcycle is going is greater than the maximum speed, therefore the motorcycle is not safe. Fine, do we get this in here? Next, let's see one more sum, guys. A motorcyclist goes on a track at 72 kilometers per hour. Goes on a track at 72 kilometers per hour. And leans at an angle of 45 degrees. Find the radius of the track. Tan theta is V square by Rg. Therefore, I can say R is V square upon G tan theta. I'll come to know my radius of the track. The answer for this should be 40.82 meters. Right? Okay. We will stop this here for the day. Thank you very much.